Hi, welcome to the Unit 5 preview video. In this video, we're going to preview the final section or subunit of Unit 5, which is two-step mole conversions, and give you sort of an overview of the end of the semester. So let's first start by recapping what we've covered in Unit 5 on moles. So in Unit 5, we learned what moles are, and that a mole is 6.02 times 10 to the 23 things, which is sort of like how 1 dozen is equal to 12 things. We also learned how to use one of the mole equations that are shown here in the mole map to convert to or from moles to another amount. Now, these types of problems are called one-step mole conversions. So examples of that are shown here. You'll notice in all of these problems, you are either given moles and asked to convert to another amount, or you must find moles and you're given another amount. To finish this unit, we will learn how to solve what are called two-step mole conversions. Two-step mole conversions. In two-step mole conversions, we use two mole equations to convert from one amount to another by going through moles. For example, if you were asked how many CH4 or methane molecules are there in a sample weighing 2.48 grams, you would be trying to convert from your given amount, your mass, 2.48 grams, so we would start here on the mole map, to the number of molecules, your find, and so we would end there. Now, there's no direct route to go from mass to number of molecules. What we must do is we must first convert from mass to moles, and then from moles to the number of molecules. That's why these are called two-step mole conversions, because you're going to be using two equations to go from your given to moles, and then from moles to your find. Let's look at another example. So remember, for two-step mole conversions, you're going to use two mole equations, and you must go through moles. In this example, it's asked how many grams of H2SO4 are in 1.30 liters of a 2.4 molar H2SO4 solution. So in this case, you're given molarity, 2.4 molar. So you'll start in the concentration section or molarity section of the mole map. And you're asked to find mass. So in the end, you're trying to get to the mass section of the mole map. Remember, this is two steps. So the first thing you'll do is you'll convert from concentration to moles, and then from moles to mass. All right, here's your first CFU. Which of the following is the correct plan for solving the example in the orange box below? How many grams are there in 683 milliliters of CO2 gas at STP? Take a look at the choices A, B, C, or D, and choose the correct plan for solving the problem in the orange box. The correct answer is choice A. So in this case, you are given the volume, which is 683 milliliters, the temperature, since it's at standard temperature and pressure, or STP, you know the temperature is 273 Kelvin, and the standard pressure is 1 atmosphere. So what you're given is the pressure, volume, and temperature of your gas. You're asked to find the mass. So remember, grams is a unit for mass, so you're trying to get here on the mole map. So your first step is to go from pressure, volume, and temperature of a gas to moles, and then from moles to mass. Now here's your last CFU. Which of the following is not an example of a two-step mole problem? Select all that apply. A, how much does 0.3408 moles of gold weigh? B, a 0.25 liter tank at 18 degrees contains 4.79 times 10 to the 22 helium atoms. What is the pressure in the tank? C, a sample contains 1.204 times 10 to the 24 NH3 molecules. How much does it weigh? Or D, how many molecules of NaCl are needed to make 420 milliliters of a 1.00 molar solution? So again, this is a select all that apply. Any problem that is not an example of a two-step mole problem is the one you're going to select. If you need a hint, you can take a look at these mole maps. In these mole maps, I have highlighted your given and find in orange. So you can take a look at those and from there figure out which one or ones is or are not examples of a two-step mole problem. The answers to that are choice A and D. Remember, for a two-step mole problem, you will not have mole as a given or a find as you do in a one-step mole problem. So choice A and choice D, you'll notice that you're either given moles like you are in choice A, or you're asked to find moles like you are in choice D. So in those cases, those are one step. You only need one equation to go from moles to another amount or vice versa. For B and C, you don't see moles anywhere in the problem. So when you're solving these problems, you have to take your given, convert it to moles, and then from moles, you will convert your moles into your find. So we're nearing up the end of the semester. By the time we get back from break, we'll have about 3 weeks until the semester is over. So here are some things that I just want to give you an idea of what we're going to be doing. So again, we're going to finish Unit 5 with two-step mole problems. Then we're going to complete Unit 6, stoichiometry. In Unit 6 on stoichiometry, we use mole ratios to convert from the amount of one substance to the amount of a different substance. So once again, we're doing converting of amounts, but because they're different substances, we have to use mole ratios. Those mole ratios will come from coefficients in a balanced chemical equation or from the subscripts in a chemical formula, which you'll see later. Now, the thing that's super important here is that everything that we're covering in Unit 5, we're going to use in Unit 6. So if you're not confident in Unit 5, you're going to struggle in Unit 6. So you definitely want to reach out and get help if you need it for the material we covered in Unit 5. That is it for this video. I hope you found it helpful. As a preview for what's coming next, have a quality day. And if you're watching this video before we come back from break, I hope you have a happy holidays and a wonderful new year.